understand the hyperbola, let's do some investigation. So we start off with this example. Let's consider the case where you add two polynomials together, then they are different or the same, that the sum is 1. So when x is 0, what's y equal to? 1, right? 0 plus 1 is 1. Okay, let's plot that point. We're going to make 1, 2, 3, 4, 5. Put that 1. This is, it go up by 0.2 each time. 0.2, this is 0.6, etc. Okay, so 0.6. Let's try again. Now, if x is 0.2, what's y equal to? 0.8, right? So 0.2 is 0.8. So that's 0.2. And then what if x is 0.3? Y is 0.7, because they add up to 1. And x is 0.5, y is 0.5. So like this. Alright, so you get all the points. If you join them together, what do you get? You get a straight line as expected. Okay, so you get a straight line. The equation of this line is x plus y equal to 1. So when the sum of two numbers always equal to a number, you get a straight line. So basically, if you increase the x value by 0.1, how much does y increase or decrease? So will y decrease or increase if you increase x by 0.1? Anyone? Decrease, yeah. So as x increases, y decreases by 0.1. What if you increase x by 0.2? Y will decrease by 0.2. Okay, so what do we do after this? We're now going to investigate what will happen if we change the plus into a, actually, if you change the plus into a times symbol, you will get x times y equal to 1. So before the sum is a constant, now we have a product that's constant. Let's see what we get. So if x is -1, what's y equal to? -1, because they multiply to get 1. What if x is -2? Y is -half. Can you see that? So so you have to halve the 2 to offset the 2. What if x is -5? Y will be -1/5. And when x is 0.5, actually, if you make y the subject, just put y equal to 1 over x. That will be easier. And just substitute. Actually, changes to decimal. Better. Okay, so -0.2. Okay. Fine. Okay, so we get -1, -1. That's a bit hard to sketch, but anyway, over here that's -1, -1. Okay, good. So we plot some points, and what's the next one? -2, -0.5 will be here, and the next one will be even smaller. 1, 2, 3, 4, 2, 3, 4, 5. Okay, let's do more. What if x is 0.5? -0.5, what would you get? You get -2, -2 over here. And the next one is, and then when x is -0.1, you get 5. No, you get 10. -10. They're very high. Okay, so if you plot the points, you get this shape. All right, you get this shape, and then because -0.1 times -10. Oh, very low, very low. Yeah, you can't see it on the graph. Okay, good. We'll do the same thing here. When x is 1, what's y equal to? Y equal to 1. So get a point here. And then when x is 2, y is half, which is 0.5. When x is 5, y is 0.2. Like that. And then when x is 0.5, y is 2, that will be 10. So you get this shape. We call this shape a hyperbola. So this is hyperbola. Note the spelling, hyperbola. Yeah, it's good. It has got what we call the asymptote. So what's an asymptote? We will explain in a minute. Asymptote. Asymptote. Okay, asymptotes. So we have the asymptote. This one. Yeah, so pay more attention. Okay, asymptote. Asymptote. That's a more interesting question. Now we're going to answer that after we finish. It's a very important topic. So if you know this, you will think maths is easy. So if you understand all this, maths will be easy. Then you have to work hard to understand it. Okay, now what happens if you double x? What will happen to y? Think about it. If you double x, what happens to y? Then it will divide by 2, you will halve y. Very good. So when you see this connection, when x times y equal to a constant, if you double the x, you will halve the y. Double x, you will halve y. And what else I have to say? Now, what happens as x gets bigger? What happens to the y value? It gets smaller, yeah. And if you make x very big, y gets very small. So you have this asymptote. So the bigger the x, the smaller the y, right? And then it goes, and same thing with the smaller the x, the bigger the y. So you have this shape. And this, smaller the x, bigger the y, bigger the x, smaller the y. Okay. We're going to do some more examples. So remember, a hyperbola will have this shape, has two asymptotes. Horizontal asymptote, vertical asymptote. Okay? All right, we're going to go to the next page to do more hyperbolas and see what happens if we change the 1 to a different number. Yep. Double x, half y. Yeah. Okay, good. Hopefully you're finished. We're going to move on to the next page. Okay, move on. Okay, let's move on. Okay. All right, so now you have this table of values. So this comes from x, y equal to 1. So if you make x, y the subject, you divide both sides by x, you get 1 over x. So whenever you see an x in the denominator, it is called the hyperbola. Now let's complete this table of values. So if you put negative 5 in here, like before, we get negative 0.2. For negative 2, you get negative 0.5, get negative 1, right? So you can substitute in. If you substitute negative 0.5, you get negative 2, and then negative 5. Now, can you substitute 0? No, you can't put 0 in the denominator. So there's nothing here, and then you end up getting 5 to 1.5.2. Now, you don't have to draw this because I drew it for you already. Okay, so it's at the bottom, it's already drawn. So this is y equals to 1 over x. Now, why do I want to do this? So I want to see that the bigger the x value, the smaller the y value. That's why there's an asymptote, right? The bigger the x, the smaller the y. And the smaller the x, the bigger the y. So you have this shape. Smaller the x, bigger the y. Bigger the x, smaller the y. So you get this shape. And there's an asymptote. Yes? Okay. Now, what happens if I change the 1 to 2? I'm going to use a different color pen, use a purple. So you have a 2 on top. What will happen to the y value? It would have doubled, right? Can you see that's going to be, so say for this one, if you put -1 in here, what do you get? You get -2, right? You got double. If you put -2, you get -1. And see, you got double. So we double the y value. Let's see what happens if we double the y value. Double, double, nothing here. Double, double this. Alright, so you get this very quickly from the one we just did before. And I want to plot the points on the graph below. Preferably using a different color from blue or black because it's black on your worksheet. So use a blue pen or a different color pen from the one you just used. And then we're going to plot the points and see what happens when you plot these points. Okay, let's try that. So when x is 1, y equal to 2. When it's 2 is 1. 1 is 2. And 2 equal to 1. And then you just got double. And what's the other one? 5 is 0.4. 1, 2, 3, 4, 5. 0.4. It's got double. And then 4.5 is 4. And then etc. It just gets very high. You get 10. The other one's 10 you get. Alright, plot the points. Something like this. So it's going to be, see the purple one will be above the blue one. So it's still a hyperbola with the same asymptote, except it is slightly above because it's been doubled. The y value, y equal to 2 over x. And let's see what happens with the other side, which is the negative side. So when it's -1, it's -2. So they got double as well. And then you get this point here, this point there. So the purple one will be above the blue one. Okay, you get a chance to draw this hyperbola. Alright, so you got this purple. And remember there's an asymptote, which I'm going to indicate by dotted line. Is an asymptote. Means the graph approaches but never touch. So approaches, never touch. The asymptote. So asymptote. So the x and y axis in this case is the asymptote of the curve. Right, done. Asymptote is drawn. Now after you draw it, can you see what the effect of having a 2 on the graph? What does it do to the graph? In terms of the shape, what happened? You can think of the graph has been stretched out, right? So the same asymptote will just get a bit further away from the x and y axis, right? So the effect of 2 makes the graph stretch out a bit, okay? All right, after we do this, what else we have to do? Let's see what happens if we have a minus in front. What will happen to the y value? Minus. What will be reversed, right? So this negative 0.2 will be positive. Negative will be positive, right? So it'll be 1, 2, 5, cross, 5, -5, -2, -1, -0.5. And then we're going to plot the points, see what graph you get. You'll get the same graph, but in different places. See what we get. Okay, have a try to draw it. Again, using a different color pen so you won't get mixed up with these two graphs. Okay, good. All done. Let's try to draw it. So let me see. So this one will be here. Will be there. So it'll be negative, right? So it's exactly the same. It's a reflection about the x-axis. So it gets smaller and smaller. That gets bigger. And then very big. So you have this shape. Like that. This is y equal to negative 1 over x. So when it's a negative 1 over x, it's going to be in the fourth and the second quadrant. So fourth quadrant and the second quadrant. Over here. Over here. Like that. Alright, that's your graph. Y equal to negative 1 over x. So note that when there's a negative, it's in the second and the fourth quadrant. But the asymptote stays the same. Okay? So now we know all the effect on the hyperbola. So now you'll be able to draw a lot of them. Okay. Actually, I just almost forgot. Oh, we can talk about that later. Actually, we can talk about it now. Every time we look at function, we'll be interested in these two words, the domain and the range. What's the domain? Well, it doesn't matter. They all have the same one. All real x except x is 0, right? There's an asymptote, right? You can't have 0 in the denominator, right? How about the range? That's right. All real y cannot be 0. Yeah, never reach 0, isn't it, due to the asymptote? Okay, done. We now can move on. All right. There's still few more graphs to learn tomorrow or next lesson, and we'll try not to do a lot. There's still so much to cover. Okay, let's move on. Okay, next page. Recording. Oops, sorry. Okay. Yeah, I paused it to ask you to be quiet, and then I forgot to turn it back on. All right, I will record for the next one. Okay, domain is no, next ones will be enough. All real x except x can't be negative 2, and the other one's all real y except y cannot be negative 3. X. One more. Yep, let's do the domain restricted. We haven't got to that yet. Okay, we're going to restrict the domain. What would the range be if we restrict the domain? So we're going to get a highlighter, a yellow one. Okay, so domain if restricted to -4 to 1, right? So find where 1 is. That's 1 all the way to -4. So this is highlighted. And then -4 is over here. So I'm going to write the word -4. That's 1. So the graph, the highlighted bit will be here. So you have to find the domain of the range of the highlighted bit. Okay, so this bit here, this bit here, right? Okay, so what do we do? So you have to find the range for this part. So we have to find the coordinates of these 2 points. So what's the coordinate? When x equal to 1. Let's use a different color there, black. Okay. When x is 1, what's y equal to? So you sub it back into this formula. When x is 1, y equal to 1/3 minus a 3, which is 2 2/3. Okay, work out this point, and then work out this point as well. Substitute negative 4 in, which is negative 2, negative half, negative 3, oops, sorry. Oh no. Alright, okay, how about this? I rub off the other bit. Then you can see. Alright, oops. Okay, alright, so we're going to find out the... Alright, so we have to work out this point at negative 4. So when x is negative 4, y equals to 1 over negative 4 plus 2 plus minus 3. What do you get? You get negative 3.5. So you get negative 4 comma negative 3.5. Okay, so right, so you get these 2 points. Now we can work out the range if the domain is restricted to this. Now what's the range? It's going to be above this point, all the points here, and all the points there. So you have to describe this section. So describe this section. What's the range for this part? The one that's highlighted. Yeah? You're 100% right. Okay. Oops. Okay. All right. This bit. Oops, it's all colored. All right, let me rub this off. You're right. Sorry about that. I got myself confused. All right. Oh, no. No, you're better than me. All right. All right. Okay, good. Okay, good. All right, so this section, very good. That was good picked up by student. Okay, so otherwise we would have been completely wrong. Okay, let's write down the domain for this, the range for this. Okay, let's write down the range. Okay, good. All right, so what's the range for this part? Y has to be more than or equal to negative 2 and 2/3, right? So anything above, what's the other bit? Anything has to be below, less than or equal to negative 3.5. All right, that's the new range. Yeah. This. This bit. Okay. All right, let's do next question. Oh, how do I get this? All right, let's do this again. Okay. How do you get minus 2 and 2/3? Because I substituted, listen, I substituted 1 in there. That's the equation. All right, this bit, I'll do it here. All right, okay. All right, oh, yellow is very light. So, all right, okay, now you can see. Okay, so you do y equals to 1 over 1 plus 2 minus 3, which is 1/3 minus a 3, negative 2 and 2/3. That's how I get this number. Yeah, I should have given you 1 page to do that. I'll try to... Say again? 1 there, because when x is 1, we have to restrict from 1 to negative 4, 1 to negative 4. Yeah. All right. Say again? Yeah. All right, we'll continue to record. We'll do the next one. Let's continue on. Okay. All right, okay. Yeah, sure. There you go. Alright, sorry. Alright, let's move on. All done? Okay, next question. Let's find a vertical asymptote. Vertical asymptote. That's what denom equal to 0. Watching? 1 minus 2x equal to 0. Make x the subject, half. So half is your vertical asymptote. And where half is? Equal. Equal. Let me draw this again. Half. Okay, we've got half here. And how do you find a horizontal asymptote? That's when that's been shifted up 1 unit. So the horizontal asymptote is y equal to 1. Say again? No, positive, because let's show you more working. So 1 minus 2x is 0. Move the 2x over. y equal to 2x, right? You move the 2x term to the right-hand side, then divide by 2, right? So x is half, right? Yeah. All right, now we're going to find the x and y-intercept. Let's find the y-intercept first. Y-intercept. That's where x is 0. And then use your calculator, you get 4. Right, 4. Find the y-intercept 4. 2, 3, 4. 4, okay? And then you find the x-intercept. Right, to find x-intercept, you will get y0. So you get 0 equals to 3 over 1 minus 2x plus 1. Move the 1 to the left. And then you reciprocal both sides. Okay, let's continue. Okay, so you make y equal to 0, move the 1 to the left side, and then what do you do next? You have to reciprocal 1 over negative 1 equal to 1 minus 2x over 3, like that. And then multiply both sides by 3. Like that. And you get negative 3 equals to 1 minus 2x. And then you subtract both sides by 1, you get negative 4. Negative 2x. And x equals to 2. Right, it's 2. 1, 2. Okay, good. So cross the y-axis at 4, x-axis at 2. So this time, if you draw it, it will look like this. Over here and over there. Yep. We're going to... All right, I stopped there for a while. Okay, so do you understand the vertical asymptote? Good. Half. Horizontal asymptote? 1. Y-intercept, x is 0, 4. X-intercept, y equal to 0, solve the equation, 2. And then the hyperbola must cross here and there. All right, done. Now we still have got one more part to go through. Let's finish that. Finish that, then you go. Oh, is it? Hang on. Oh, it's so long. Now between -1 and 5, watching. Shh. Yeah. Because has it been different? Had it been in, say, in this quadrant, if it's in here, it wouldn't cross the y-axis. That would have been wrong. Yeah, because of the minus x. See the minus in front of x? That's why it caused it to go like this. Yep. Yeah, good question. Yeah. So that's why I wanted to find x and y intercept first so that I know where to draw rather than on the other side. Yeah? What else are there? You have to find the range, find the domain given the range. If the range is between -1 and 5, from -1 to 5, what would the x value going to be? Okay, let's try to do this. So, okay, let's go through. Okay, we're going to answer this part. Okay, all right. So how do we answer this part? So what you do is, all right, okay. So between -1, now given the range. Oops. All right, so here and, can't do it, okay. All right, so this bit from 5 to -1, what's the domain for this? Okay, all right. So let me highlight the part that we're looking at. Yes, yes. Okay, all right. So we're going to highlight the graph from -1, which is over here. That's -1. Over here to there. And then everything here up to 5. Okay. So this bit from -1 to 5. Not the whole thing, up to 5. Stops at 5. Right? Yeah. So up to 5. Up to 5. So let's work out what that point is. Let's work out the point. So we get black pen. Okay, so we're going to substitute. Oh no, it's very hard. Okay, so bye-bye. Okay. So, okay, all right, let's do this. Okay, when y is equal to -1, what's x equal to? So you substitute -1 into the formula. -1 equal 3 over 1 minus 2x plus 1. Should have picked the easy example. Okay, anyway. And then you're going to move this to the other side. We'll try to find the x value where x. So what that point is. So y is -1. What's x? So we substitute -1 in there. And then we're going to move the 1 over to get -2. And then you reciprocal both sides. 1 minus 2x over 3. And then multiply both sides by 3. Like that. You get -3 over 2, which is 1 minus 2x. And then you keep going, which is -5 over 2. -2x, so x equal to 5 over 4. So it's 5 over 4. Right, so this point is 5 over 4x. Okay. And then you have to work out the other point. The other point occurs when when y equal to 5. So y equal to 5, you get 5 equals to 3 over 1 minus 2x plus 1. And then you're going to get 4 equals to 3, 1 minus 2x. And then you reciprocal both sides, 1/4, 1 minus 2x equal to 3. And then you're going to continue and find 3/4 equal to 1 minus 2x. And then subtract by 1, you get negative 1/4. X equal to 1/8. And then once you do that, put that point here. So it stops at 1/8, 5. So that tells you when you restrict the range in this way, then the domain will be, so the answer to the domain will be x has to be less than or equal to 1/8, or x has to be more than or equal to 5/4. Yeah, it's a lie. It's a hard lesson. Okay. Well, it's in the textbook, so it could be potentially in the exam. Alright, go up. Okay, good. Alright, so done. Okay, so